Okay, so we're COMP100, week 4, lesson 4, part 2. So we did a bit of a review. Now we're going to go into some new stuff. Before we get into the new stuff, though, one more thing I'd like to say is we can also add something called comments, right? Comments on to our program, right? So we have our actual code. This is our code up here. But now I want to make some comments. I want to describe what my code is, or maybe add some remarks, some information about the code. Now the code should really describe itself. If it's cool, it should comment itself. You shouldn't need too many comments. But at least for now, it's like this is our first program, right? And the way you do comments is this double /, right? That's a single line comment. If I want to make a multi-line comment, I can do that. If I want to go before the main, I can kind of say /*, right? If you notice, everything turns green. But I'm going to start typing. I want to say, this is our main method. And then I'm going to go to the next line. If you notice, there's another asterisk, right? We place, yes, we play all of our lines of code here.
That's notes?
Yeah, it's like notes. And I go back to the next one. If I do / again, right, then it closes off our multi-line comment. So it starts off with /*, and we have to end it with */, and then anything between these two lines, these two symbols, groupings of symbols, is our multi-line comment. Okay, so it's again just an ability for us to add in a little bit of text. This text is ignored. Anything in green like this, and again this single line comment and this multi-line comment, anything in green like that is ignored by the compiler and the program. So it will not do anything with it. I can put whatever I want, close, right? I can put anything I want in here, and it won't do anything to my code. It won't affect my code at all. Now, if I cover my code with it, like if I do one of these, if I say //, and I put it at the beginning of my code like this, right, in one of the lines, if you notice my code all goes all green. So //, I just effectively commented my line out. That's what it's called, commented out, right? I don't want to do that. I don't want to comment my line out, right? So I can uncomment it by taking away the two //. So if you try it yourself, again, // adds a comment. I can comment out a piece of code, take it away, and it goes away. If I want to comment all this out, I can do the same thing with this multi-line comment structure. So /*, right? And I go to the bottom, right, of my code, including my, let's say not including my thing, and I go */, and all of that is commented out now. Right, so there's nothing inside of this that works. And if I run this thing the way it is, because it's all commented out in green, and if I press play here, I'm going to get nothing. It's going to go whoop, whoop, hello and goodbye, right? Because now none of these lines of code are running. They're not being accepted by the compiler. They're actually hidden from view. They're removed from our build, right? Anything in green like this, and it's made green by the compiler, by Visual Studio 2013. So if I can uncomment it the same way. I can just take away these remarks here, and then now my code comes back. Yes?
So what happens if you run it like that?
Like this? This is fine, because this code here is ignored, and so is this. This line here. It's not code, it's just a comment. So if I run it, now it's running fine, because it's not mute. What it does is it allows us to create some description of what our line could be doing, right? Or either way, whether it's before the code, like this, and like this is before the code, and you can put it even inline. I can take this comment here. There's an option to cut it out, Control X, or you can right-click it and put it behind our code like this, our line, on the same line, and it's okay too.
So it's just pretty much for other programmers to see notes from other programmers.
Correct. And actually, even better, you to see notes from yourself.
Oh yeah, that.
Like I add a new piece of code here. I forgot to do this one. I haven't implemented this. Those kind of little codes. Also things like this function does this operation, whatever the operation is, if you don't know how to do it.
Study notes.
Sorry?
Write down the code and then you put a comment beside it, writing up what it is, and then
It's too much. You don't want to, one thing you don't want to do with comments is you don't want to comment every single line. I'm going to ask you not to do that. Right? So when I ask you for comments, like to comment your code or include internal documentation, well, that's what it would be, right? It would be simply for breaking up your code, as an example, or like with maybe some dividers, like just using comments to divide your code up so you can see it more clearly here on the preview. On the right, if you see on the right here, when I look down, I can see that there's a green line here. If I had a big line of code at the top, I'll just get rid of this, and I go like this. And if I had a big line of code like this, like a bunch of pluses, they don't count. They're ignored by the compiler, right? And now when I look back up here on my preview, I see that there's a big line, so I know that's the top of my code. So it's a quick way of knowing how I can break up my code if I need to. And it also kind of separates it and it makes it look different. But the way it looks has no bearing. It does nothing for your code itself. It is ignored by the compiler, ignored by when we start running our code. Anything that's in a comment. That gives us the ability to isolate our issue like we talked about last time. We talked about trouble isolation, the idea of trying to figure out where our problem is. And what we can do is we can remove or comment out sections of our code. For example, I don't know maybe why this is not working properly. So I want to remove these 2 lines of code, right? Like this. Well, I can do some comments. I can go comment, right? Comment. Now those lines of code are gone, and now I can run it without those 2 lines, and without me having to retype anything.
what's the difference between having 2 dashes and 1 dash?
Which dash are you talking about?
This thing, man. What's this thing?
It's a forward slash.
Forward slash, yeah.
Yeah.
You had one of them, what, last time, like a second ago, you had one with 2 forward slashes, the start of it, and one with 1.
So let's go over it again. So the double forward slash like this is a single line of code, right?
So you can only use it for 1.
For one line. If you use a forward slash and an asterisk, the star, right? Then this is the beginning of our comment block. And down here, if I press the asterisk the other way around and forward slash, that's the end of our comment block. That tells us this whole line.
Select.
I can select this whole block, and this is all commented out, the entire block. I don't have to go line by line. Sometimes this is easier than commenting every line individually, because then you have to go back and uncomment everything by hand as well. All right, so if I go back and take it out, a lot of times we can comment out code like this, as an example, and sometimes it'll give us the ability to do that within Visual Studio itself, right? For example, it gives us the ability to refactor, right? Like you can remove or extract or reorder. And there's going to be some shortcuts that I'm going to show you, not right now, but I will show you as we go forward how we can refactor and remove pieces of our code in and out. Right now, let's just use the way we're doing it right now. If we need to add a comment, you can do so as you go, right? So these menus give us additional functionality to do different things to our code. How you doing? You're here with me today?
No.
Or you're just coming to visit me?
I saw you, so I said let me visit you.
All right. Okay. You're going to stay around?
Yeah, I'll stay around because I wanted to ask you a question.
Sure.
Yeah.
All right. So again, comments, we can take the comments out. So here we can take our comments out. I don't need these comments. I'm just going to erase them, right? And again, we can kind of remove. There's a bunch of white space. Again, our compiler largely removes or ignores any white space within our code. So again, our editor, just as a recap before we move on to more detailed things, our editor gives us the ability to write code, right, in a certain order. And remember, right now, the compiler goes line by line. It starts off at line 1, goes to line 2, and tries to read what we're telling it to do. It starts, when the using statements, it includes in the background additional libraries of code that you cannot see. So we have additional functionality we can use down here in our code, right? It comes to here, to this namespace, which is the main folder where our program is being held. Then it goes into the program folder itself, this part here. This is our class, right? Then it kind of goes down to our first method declaration, which is here, our main method declaration, right? And then it starts going line by line. Okay, I want to print hello world to the console. Okay, I want to throw out a new line to the console. Okay, the next one. Okay, I want to have all these pluses print out to the console. Okay, I want to go to the next line. It's going to show this message, press any key to exit on the console. And then finally, it's going to wait with read key, this new command, it's going to wait till we press a key. So that's how the compiler goes through. And then when it goes to the bottom, it says, okay, now I'm done. I'm on line 24, I'm done. I've done all everything that the human person has programmed into me. I'm done now. I can simply wait. And I'll be waiting here, right, on line 19 forever until someone presses a key. If someone doesn't press a key, it's going to just hang there. And it'll stay there. If it was able to last, if we just kept this program running, it would stay there till the end of time, until time collapsed in on itself. It would just keep waiting, or until the computer lost power, or the screen blew out, and the processor would stop working. It would keep going forever because that's what it's doing. It's going to wait. Now we can program it so it doesn't wait. We can program it so it only waits 30 seconds. We're not going to do that today, right? But we could. We could program it so that this read key command with some other statements in here we haven't learned yet. We could program it so that it waits, but only for a certain length of time. Okay, so that's a kind of an easy recap of what we did last week, and now we're going to add some more information to our code. All right, so we're going to talk about variable names, like we said, different data types and what they are. What is a data type? We'll talk about that a little bit, and then accept input from the console. You need to do this step 11 here, because if you can't do this, you can't do your assignment number 1. Okay. All right, so let's talk about variables. So there's different kinds of ways we can store data with computers, right? One of them is we can create a constant, right? And our constant is a name. We use the const keyword, and we use a friendly name to describe a memory location where the data will never change. Example would be if we had, let's say, the exchange rate between here and the States, right? And if we knew what that was, like let's say, for example, we knew that the exchange rate was 1.25 American to Canadian, right? And if we would declare that as a constant, that would never change in the life of our code, right? So if we wanted to multiply that constant or use that variable, that memory location, to multiply or use it as a factor to calculate, that would be a good use of that. It would never change. And when you declare a constant, it's unchangeable. It's unmutable. It's always the same. And if you try to change it in your code, it will give you a syntax error. It will stop you from doing it. So constants have their place. If we're making a video game, as an example, and I want to give a player a number of lives, right? Let's say I want to start them off with 3 lives. Lives might be the constant that we declare, right, at the beginning of our code. Say, so player lives, would be the constant. Then there's a literal constant, right? A literal, right, is something that we use, like for example, the number 1. That's a literal, right? Or the stuff that's in our quotations. We quoted something. We put it in there. We can't change that, what we put in there. We could change the value of what we put in. If we assign a number to a variable, we could change that. But we can't change the number itself. It's called a literal, right? So that's the other type of condition. And the next one is a variable, which is, again, a friendly name for a memory location, right, that we're going to use so we can manipulate data, so we can actually store data in there and retrieve data from the memory location. We can put some value in this variable, a friendly name for the memory location, and call this friendly name to use it to do stuff with. Okay? So that's what the variable means. So there's a constant, again, a friendly name that for a memory location that never changes its data. It's always the same, right? A variable where we can change the data in a memory location, and a literal, which allows us to put memory in. We'll talk about that, what that is. Then the fourth one, which we're going to talk about today, is called a data type. When I put memory or a kind of value in a memory location, I got to declare what type of value I'm putting in there. Is it a string of characters? Is it an integer? Is it a decimal of some sort or whatever, like a floating point number and so on. And we'll talk about those, what they are. So these are the most common data types that exist in most C-influenced languages. So here's one. The first data type is called a byte. And literally, it's 1 byte long. And the largest value is 255, the number 255. It goes from 0, which is the smallest value, to 255. We can use this byte data type to declare a variable. And the same thing goes with some of these other ones. Now, we'll probably never use byte as a variable name, as our data type. We'll be using the following, the most common ones. Int for integer, most common, right? Float for floating point or decimal point. Sometimes we'll use the double, sometimes, or the decimal, right? A lot of times we'll use a character, char, right? Or bool for boolean, right, as an example. And then there's also more complex data types, like a string of characters, right? So these are the type of data types we have in C#. And this is what they mean on the right-hand side. And this is how much memory they take right here. So if you notice, a byte is the smallest type of data type, right? Well, that and a bool, right? They're the smallest types, right? They take up 1 byte of data, literally a byte. And again, remember how it works out for memory locations, right? If we want to talk about data management here for memory, 1 byte, if we were talking about a kilobyte, is 1,000 bytes, 1K, right? 1 megabyte is 1 million bytes, so 1 million of these, right? 1 megabyte. And of course, we're dealing with gigabytes, right, which is 1 trillion of these, right? 1 trillion bytes, right? And then there's terabytes, and you get the picture. It goes to the next level. 1 billion. So I said 1 billion. 1 billion for gigabytes, and 1 trillion for terabytes. Sorry, that makes sense. I made a mistake.
Is there anything higher than
There is.
right now?
Right? Yeah, there's a quadrillion. Right? There's that's the next level. Billion. Right? Then there's a billion, trillion, quadrillion. Right? Quadrillion bytes. But for you to get to quadrillion bytes, it's not a terabyte. I believe it's a nanobyte or something like that, or a petabyte.
What do you mean?
That's what it's called, a petabyte. There's different names for different. And actually, if you look it up, if you're really curious as to what that is, so if I go online and if I look at,
servers wouldn't use a terabyte, they'd use something more, right? Or something.
well, several terabytes, right? But if I go to, probably petabytes. But if I go to terabyte, right, to understand what that means, and if I go to Wikipedia here, megabytes, gigabytes, terabytes, hey, what are these things, right? And if you notice, here's where we are. 1 kilobyte, right, is 1,000 bytes. 1,000 of those byte. 1 megabyte is a million. 1 gigabyte, right, as the end is a billion. 1 terabyte, which is one of the most common numbers right now, is a trillion. And then there's a petabyte, which is the next one. There's an exabyte. I know companies that use exabytes of data.
Really?
A zettabyte, yes, and so on. And there's ones that we haven't touched yet.
Yehotabyte. Imagine that's going to be like the next 30
Exabytes.
years, right?
Well, we'll see. In our lifetime, we'll probably see a zettabyte for sure. Definitely, we'll be up there in terms of big data right now. We're going to get up. We're going to be beyond this little list here. Why? Because we have so much data in the cloud right now. It's phenomenal. It's crazy. This is so-called this big data revolution we're going through right now. But again, this is something as an aside that's kind of outside of our scope. And if you notice, 2007 was our first terabyte. 2008 was our 1.5 terabytes. 2009, 2 terabytes.
Going up
right?
like this.
Here's 2013, 6 terabytes, right? Our drive, right? And we don't know what 2014 and 2015 were yet. But here's a 4 terabyte hard disk, right? And what it costs, approximately. So you can see, but if we went back in time, right, we couldn't afford, back in the day when I first started programming, I could only program with the whole computer everything, memory and everything, had 4 kilobytes back in the
4.
day. That's how much it started with, 4K. Some computers had 16K, and you were lucky, right?
You were like a rich kid.
And you know what? I had a Commodore 64 that had 64K of memory, and people were wowed. They couldn't believe what I can do with 64K of memory, right? And now 64K of memory is not even, it's so small, it's not even, your watch is bigger than 64K of memory. Even the cheapest watch you buy from like Dollarama, right? My point is that in terms of orders of magnitude, we've been going up. But so when we talk about bytes, these little pieces of data here, hold on, these little pieces of data here, right? This is how we store our data. This is the actual amount of data in terms of space that each of these data types take up, right? So the bigger the data type, for example, if I go to int, it takes up 4 bytes. And it goes, here's the number, look what it does here. It's a negative, 2,147,483,648 to 2,147,483,647. So that's the net from a negative to the positive. It does both negative and positives for an int. You can also do an unsigned int. That's what a uint is, right? A uint goes from 0, right? So the same amount of data. So they're both 4 bytes, but it goes from 0 to 4 billion, right? And they're whole numbers. Integers are whole numbers. You don't have any fractions, right? Longs are like, there's 2 types of longs. There's a signed long, which is a negative to a positive, and there's an unsigned long, which goes, 18 times 10 to the 18 in terms of precision. A really long integer. Usually we don't need these long integers for anything. And I said the most common integer we use is this one, right? Which is more than enough. Very rare do we use something like short or a small byte, S byte or a byte. We don't do that. Signed byte or byte, almost never. This stuff here. Same thing with float. Float is a very common data type. It's, again, what we use is it's a floating point number that takes a decimal point. And if you notice, it goes from negative 3.4 times 10 to the 38, so really, really accurate, all the way to 3.4 times 10 to the 38. It's really big, right? There's also a double, which is double precision, right? Floating point. So, and it also takes up twice the memory. From 4 bytes, you guys are laughing, but to me in my day, that's big. 4 bytes to 8 bytes, right? And then it goes, and the decimal, which is the biggest one, is fixed precision number. So minus 7 times 10 to the 28, all the way to 7.9 times 10 to the 28. Big fixed precision, 16 bytes, a big decimal number, right? Here's one, car or char. It's pronounced both ways. It's a character. It's 2 bytes, and what it does, if you notice, this is hexadecimal values. And the reason why they give hexadecimal values is because it can be any Unicode character. Unicode characters can be anything you type in your keyboard, an L, an M, an A, a 1, a 2, a star.
F is 15.
Sorry?
F is 15 in hexadecimal.
F is, yeah, it's, sorry, it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is A, right? Right? And then 11 is B, 12 is C, right? Get it? Okay, so then we go to bool. A bool is only 1 byte, but it only stores true or false. So it's a value. It's almost like a flag. It's a 0 or a 1. And that's why it's only 1 byte. It's one of the smallest units of measure. And actually, we use it as that. It's binary, yeah. So it's either 0 or 1, but usually we want it to use true or false. So if I want to know if something's true or false, and that's all I want to know, we limit it and we store it inside of a bool. And usually what we want to try and do is use data types that are contextual, that mean something for our code. So we're not going to use an integer for 0 and 1. That makes no sense. Why would I make an integer? It's huge. Integer is like 4 bytes, right? Minus 2 billion whatever to positive 2 billion, right? For a 0 or a 1. I don't need to do that. And that's why we have bools. It's more efficient to have these smaller data types. If you want to spark up your code and make it run faster too, and you do a lot of calculations, and you only go from like 0 to 255, Maybe you want to do a byte, right? Smaller unit of measure, less memory that it takes, especially on a, where it counts now is on one of these, on a phone, right? Here we have to conserve memory for now, right? For now, you know what? I only maybe have a gigabyte of memory on this thing, right? On average on a smartphone, right? Or maybe 2 if you're lucky, right? In the future,
That one's
iPhone 6. In the future though, this is memory, not storage. 2 different things. Memory is working memory, random access memory that you use. Storage is what we physically put here that's stored for long term, right? So my version of my iPhone 6 has about, I think it's a gigabyte of RAM and 128 gigabytes of storage, right? 128. Tomorrow, in the future, for our phones, we're going to laugh. We're going to talk about about our phones like I talked about 4K of memory, right? We're going to say, hey man, do you remember those days? We only had a gig of RAM, right, on our phones. And now, you know what? I got a petabyte of RAM on my phone. And I got like, you know, an exabyte of storage on my phone. Right? And you were like, today we're like, why the hell do you need that? And maybe tomorrow our phone is holographic or something else that requires that kind of output. And our processor is so powerful, right, you know, in the future, that today we have our phone, and it's you know, it would, if we had a processor like this on our phone right now, it would take up like the whole college in terms of space. That's how big our processor would be. But tomorrow, maybe, you know, 20 years from now, it'll be the size of like a, you know, a thumbnail. That kind of processor, the power that I'm talking about. Who knows? Who knows what's going to happen? But my point is, as we go forward, right, the way we manage memory and data, it becomes less meaningful. Before, in the past, it was really meaningful. From a performance perspective, we tried to reduce the amount of data that we used in data types. Today, what we want to do is we want to use types of data to reflect what we're doing in business. So if I'm going to do a cash calculation, I'm probably going to need some kind of decimal or floating point number because cash usually has dollars and cents. 1.34 dollars as an example, right? I need that. Although in Canada, there's no 0.4 anymore. There's 1.35 will be the minimum. 5 cents. There's no pennies anymore here, right? Which is unheard of. If you told me that like when I was a kid, you know, because it was 25 cents to get on the bus, right? You know, back in the day, and 10 cents. Oh yeah, man, right? It was 5 cents to make a phone call, right? It was crazy. It was like it was really, really cheap back then, back in the day, right?
You know,
but nowadays it's impossible.
Technology is getting more advanced, but things are getting more advanced. Like it should be like a phone call, should be cheaper.
You know you're being recorded, right? Okay, let's continue.
I don't care.
So when we declare variables, if we do math, right? When we declare variables, it looks like this. We declare the data type. This is our general form is what I'm going to call it. Our data type is declared with our data type first, followed by a friendly name for our memory location we call a variable in this case, and then followed by this assignment operator. This is an assignment operator that says that I'm going to take this literal, this is a numeric literal that can never change because I've typed 2.5. What I typed can never change, 2.5, right? I can't modify what I typed here. It's whatever it is. And I'm assigning it, I'm putting it inside, see the little arc I'm doing with my mouse? Inside, it's being stored inside my age variable, which again is an alias or a friendly name for the memory location that it's going into. Right? That's all it's doing. This assignment operator equals is doing that operation. It's a little backwards from what we do in math. In math, if I say my age is equal to 25, I can take my age and replace my age all over the place, right? And sometimes if I say my age is equal to my age plus something else, don't do that in math. It doesn't make sense from an algebraic perspective. But here in computers, it makes perfect sense. I can declare multiple variables in the same type, for sure, on one line. Not a good idea. I'd rather do each line separate if I can. And I can declare the 2 variables of the same type in a single statement, separated by a comma. I don't recommend. Let's take a look at doing that. So I want to create a variable here in C#. So let's go back. I'm going to switching back and forth here, right? And here I want to create a variable for the year, right? Now what variable would be a year? It could be an integer, right? Because the year is a whole number. So if I call my variable year, I'm going to say int. I'm going to start typing, and IntelliSense is going to bring it up. Right now, if you notice, it says int int16, int32, int64, and so on. And there's an interface, all kinds of other suggestions, right? But all we need is the first one, int space, and the name of my variable. So we're going to call it year, lowercase, right? If I did this uppercase, this goes against convention. Typically, we don't use an uppercase name for a variable. Usually for a variable, it's lowercase starting off, right? And then I press a semicolon. A semicolon basically says, I'm done typing my statement. Now, this little underline here, it comes up. It says, the variable year is declared but never used. It's a warning that the compiler, it's checking through our code all the time. It's checking through and saying, I don't understand what that is.
You didn't put
Right?
a number. You didn't specify what year.
I don't need to. I'm just declaring it. When I do this, I'm doing two things. Here is the data type itself, the integer. I'm saying I'm declaring an integer,
Number.
and this is so a positive, negative integer, or a positive and 0,
And zero.
right? But whole numbers here, from minus 2 billion to positive 2 billion something, right? And I'm declaring a friendly name called year that I'm using to kind of label my memory location. That we don't care what the memory location is. It's just a memory location that the computer is going to allocate for us, right? Back in the day, we'd have to tell the computer a specific memory location that we wanted to put data in. Today, it doesn't matter. It's random. Okay, I haven't declared the value for the variable. I can do it on the same line like this, right? That's a value. Or I can do it like this on a different line. I could say simply like this. I can assign the value here. Year is equal to 2015. Both ways works fine. You see? I can do this all in one line, or I can assign it on a separate line.
How come it still has that?
It has this second line because I haven't really used this value. I haven't done anything with year. I've assigned the value, but I haven't
Why
used
do
the
you make it
variable in
one
anything.
line?
How do I what?
Is it just
It's just this. For one line would be this. In the same line that I declared, I can do one of these.
Yeah.
So I'm assigning it in the same line that I declare it. Typically, we don't do this a lot. We want to try usually and declare a variable of a certain type. We say the shape of my variable in this particular case, right, is 4 bytes long. It's an integer. From negative 2 billion something, including 0, to positive 2 billion something. That's the range that my variable can kind of fit inside. And to kind of demonstrate that, if I just go here and use the variable and I go higher than 3 billion, like this. So I go 3 billion, da 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 da. So this is 3 zeros, 3,000, 3 million, 30 million, 300 million, 3 billion. Go farther than that, and I press enter, and I do that. It's going to give me a squiggly because it's beyond the range of my integer. And it says, hey, error, cannot implicitly convert type long to int. Because that literal, this number here is considered a literal, a numeric literal. That's what it's called, right? It's bigger. It's so big it can't fit into the integer that I've declared. So that's why it's giving me this error. It's going, we have to convert it. If I made this long, if I change this to long, right?
So
And
long
it would
is
work.
Long integer?
Long int. Yeah. If you go back to the PowerPoint presentation for a second, if you notice what it says, if you notice what it says, it's from 9 times 10 to the 18, minus 9 times 10 to the 18 to positive 9 times 10 to the 18. It's a big number, right? 18 zeros, big. And this is a signed long int. If I go u long, it's even bigger because then I don't have any negative. An unsigned int or an unsigned anything means there's no negative numbers. It's only 0 and up. So if you want to limit, if you want to check to see that, oh, you can only get positive numbers, right? Then you make something unsigned. And you can do that for ints. But you cannot do that for floats, doubles, or decimals. You can't do that. They're all positive. They're all negative to positive. Okay, so I've done this, but obviously we're not in this year. We're going to go back to 2015. But is this really a representation that we want? 2015 is actually a value. That means it's 2015. We're not going to do anything with this value. We're not going to add it to anything else. So really, an integer is the wrong data type. Even though it shows to us, it means 2015 to us, it's really not the right data type.
It's
We're
not like
saying
a date, year thing.
we can. This is the year. We can say the year is, in this particular case, is an integer. Well, we could simply put the integer. If we're going to just print this out, then string would be sufficient as well. If I said string, and if I left it like this, it's going to give me an underline. It's going to say, wait a minute, you need to use single quotes or double quotes around a string literal like this. Now this, even though it's a string literal, fits into a string data type. When I put my quotations around it, it's no longer an integer. It's no longer something I can make an operation with. I can't add it, subtract it, multiply it, or divide it. It's a string. It's like words, right? Yeah, characters.
Didn't you say last time that quotations can only put should only be put around words? Numbers should be.
But this is a word. It's almost if I was going to read a book to you, and if I said 2 days ago with a 2, right? Or
Okay.
he gave me $5, right?
Yeah.
I could write out 5, F-I-V-E, and I can also use 5, the numeric, representation of 5. But I'm meaning it as words,
Okay.
right? A character as opposed to a value that I'm going to add, subtract, multiply, divide. If I'm not going to add, subtract, multiply, divide, and do any operations on a value, it's not a value. I might mean it as a string. I might need it as a representation that I'm going to show. I'm going to display something, but it's not something that I can add, multiply, and divide with. So if I was going to just display this string, and I wanted to add it into an output, hello world, and I want to give it its own output. For example, I want to add it on to 2015, right? I can simply go like this. I can say console.writeLine, and I can say year, right? Now console.writeLine year is going to take the value that I've just, I use my assignment operator equals, that's what it's called, and I assign a string literal of 2015 to my friendly name for a memory location variable called year, right, of type string. I've assigned this value here, and now I'm accessing, here's where I access the value. I'm calling up the value of year here in my when I invoke this statement. When I call up this statement WriteLine and put year in here, I'm taking the value that's stored here and printing it out here. If I run it, now I get this. Hello world 2015. So we did it 2 ways. This is our hello world with a string literal right here. And here is the year where I've taken the value of the year and put it here. Now I've declared it. I've declared my declaration. When I say declaration, it means I define the variable that I'm using, and I also assign it on the same line. Not really best practices. Yes?
I have a question. What happens if we made an integer year and then we put it in a right line?
I could do that.
Would it still work?
Let's try it. So integer year, so int. I have to convert this back. It can't have the quotation marks. It's got to go back to being an actual number. And if you notice, the program, our Visual Studio 2013, recolors this to make it black, meaning it's a literal. It's a numeric literal that I can work with now, right? Before, when it was a string, it was this color, this reddish color. So we know it's not something you can add together. It helps us to identify the difference between a number, an actual number we can work with, and a string value that we can't really work with, add, divide, multiply, or whatever, subtract. Okay, so I want to put this is what you're saying. I want to put this into the year. Well, I've already done it here. Look. So I've got my year, my integer variable here, and I'm going to print it out. Let's see if it shows us the value of 2015, and it does. So to the console, we can send strings to the console, and we can also send numbers to the console, like integers. Didn't work? Yeah, it works the same way. Integer, string, when we send things to the console, it's the same. The difference is I can't do anything with a string value, but I can do something with this. Okay, year is interesting. So hello, a world, and year, right? Let's go back to here and make sure we're on track. So this is where we declare it, and this is how it would look, right? Here in this particular example, if you look up here, we have a variable name, a friendly name from a memory location, variable, that we call, it's named some money. And if you notice, our variable naming convention, right, is like this. We start a variable with a lowercase, and then when we come to the second word, if the variable is made up of two words that we understand, we have to capitalize it. It's called Camel Case, like we talked about. We kind of talked about that last week. So Camel Case is this: lowercase s for the first part of the word, and uppercase for the second word. Camel Case, because there's the hump, right here. Here, if you notice right line, because it's a method, the convention is upper camel case. It's also called Pascal case, and where you have two capitals, capital here for the W and capital here for the L. That's our convention. That's what we're going to be using, not because we have to, because everyone else is doing it. It's something that's best practice, so you can identify the difference between a variable and a method, or a class. Okay, so this is just the variable. It's of type double. When we put double in front of it, it means this variable is, I'm defining this variable of type double, and I'm assigning it in the same line using the assignment operator equals. I'm taking this value, 39.45, and putting it inside some money, this variable called some money. And then I'm shooting it out to the console by invoking it, by using some money to replace the value that would be going in here into the right line statement.
It would be 39.5.
39.45 is what it's going to print out. And here's the example. So here's 39.45. This is right from your book. Okay, here's another example. Here's display money 2, another kind of example. I have this variable, right? Here it is right here. Take a look. Except this time I use a write statement. What's the difference between a write statement and a write line statement? Do you guys remember from last week? Anybody can guess what it is? The difference between a write statement and a write line statement. Well, a write statement also writes to the console, but doesn't enter a new line.
Oh, yeah,
The
yeah,
write
yeah.
line statement writes to the console and then skips to the next line afterwards. So if I want to write on the same line, I could just do this, just like it's doing here. Console.write, and then my variable afterwards. So let's try that. So here's year, right? And then I want to kind of do a console.write ahead of it. I'm just going to give some space here. Here's console.write. And I'll say hello, and then 2015, right? Hello, 2015, right? That's what it's going to say. And I'll just give some space here so you can see what it is. So these two statements are going to go together because they're on the same line. Now you notice there's this red squiggly that comes underneath here.
Wait.
Yes.
Wouldn't the hello go on the one that's over, because you didn't like write line up again, so you didn't make a new line technically. So wouldn't that go to the one over?
Nope. If I don't use a write line, if I use a write, it stays in the same line. So for example, hello doesn't go to the next line before the next statement executes. So the execution goes like this. When I say execution, it means the line is run. It's interpreted by the program, compiled into machine code, and then run. It's actually it follows my instruction, right? It's called code execution. Wait, let me answer the question for you. So that if I execute, the compiler then executes or runs each code in order, each line of code. So if I go to here, it runs this one, prints it out to the console, goes down to this one and says, you've issued a command to execute this string literal and print it out to the console, but you haven't told me to go to the next line. So I'm going to stay on the same line, and then I'm going to print out the year, and then I'm going to go to the next line. Get it?
Makes sense.
So now let's try it out. So I'm going to run it, and if you notice, it says, hello 2015, right? So here's hello world and hello 2015 on the same line because I've used a console.write as opposed to a console.write line. Two different methods. One adds a new line character, and the other one does not. Okay. So that allows us, in this particular case, to put, the statement together. Okay, I want to format my string sometimes, and what I use is a format string that allows me to tell the compiler when I send things to the console, the way my text is going to be arranged, if you will. I can style my text in a way. So, for example, it says a string of characters that optionally contains fixed text. I can move things around and make it look a certain way by formatting my string. And I can also, sometimes I need to use a placeholder to do something called string interpolation. Okay, there's a special role that we can do, so we can sub in, right, a value into a string by using a placeholder. Let's take a look at how this looks. Okay, here's one. So here's double. Take a look up here now. I've got some money, right, and the value is 39.45. That I use my assignment operator to take this value and put it into some money, right? Then I do a console.writeLine, and I say the money is, and I use this $sign to say it's money, right? And then I use this curly braces. These curly braces are, and the 0 in the middle is a notation that we use to say this is a placeholder where I want to take some money, the value of some money, and kind of replace this little notation with the value of some money. All I'm doing is swapping it out. So it's almost like as soon as I put that open curly brace, the 0, and the closed curly brace, that's telling the compiler to say, take this, the next available variable after the comma, and put it in here. It's called string interpolation. I'm actually taking it and interpolating the value. I'm actually swinging it into that string. I can put it anywhere in here. It's going right in the middle of this string, actually. So this is a string value, and I'm taking some money and putting it inside. Well, let's try that with our year, right? So our year, I have 2 lines for this, but I want to put it on 1 line. So I could simply do one of these, right? Let's say, hello world. We'll use that line, that console command up here, right? And our console command, I'm going to kind of interpolate. I'm going to use string interpolation to add in our string or a number right after hello world. Well, I can do that by doing this. Open brace, a 0, and the closing brace tells me I have a placeholder. Then I can use the comma, right? And if you notice, code hinting tells me, hey, look, I can put in, here's my string format, and here's my additional argument that I can add in here that I'm going to put into this string. I'm going to kind of plop it into the area where I have these 2 braces, right? So here's year, like this. So I'm going to take year, and wherever there's these first braces, it's going to take the value of year and plop it in here. So it's going to read like this: hello world, exclamation mark, space, 2015. That's what it should be. That should be the output. Let's try that out. And here it is. Hello world, space, 2015. And new line. We get a new line because we're still using this console.writeLine command, which adds a new line character. It's a special character you can't see at the end of your string to take us to the next line. It's an escape character is what it's called. You can't see it, but it's tied into our writeLine statement. Okay, let's go back over here. So we've done that string formatting thing. All right, so here's some examples of more string formatting, right? This is interesting. I've got, when I format string values, I've got this value 4, and I say from 0 to 5. That's really weird, eh? What is that? What could that possibly mean? Right? So 0 to 5, right? And 4. Why is this extra space? Why do we have to have this space in here? So it's 0 to 5, and then it says 4, the value 4. Let's try that and see what it gives us. So if I was to do that, just to check it out, console.writeLine, right? And I'll leave the space, and I'll say, just to go back and do the exact same thing, right? So open curly brace, 0, comma, 5, close curly brace, right? And then we're going to put at the end of the string a comma and a 4. Okay, and a semicolon, of course. So let's see what that does. I'm going to kind of run this thing and see what we get. Well, there it is. What has it done? To my 4. It's there, right? Hello World 2015. There's a 4 there. But if I didn't have this string in here, right? If I didn't have this funky little string in here, I'm just going to take it out for now. I'm just going to erase all this. I'm going to cut it out and run it. Then the 4 becomes here at the beginning of the line, right? But when I put it in,
So skipping sort of space, right?
but it says 5. Why is it giving me 5? It says represents text as a series of Unicode characters. This is what this string is, right? So in here we have this format. Okay, let's go back to the example again because we learn by doing. Okay, here's 56, right? So 0, 5. Why 5? Why not 4? It doesn't look like 5 spaces. If I go back and I run this thing and I count, I go 1, 2, 3, 4, 5. Which means I've given myself the 5th position is where this number falls. I have 4 spaces before, but the 5th position is where my number is going to appear inside my string. I'm actually pushing my number over to the 5th position, the 5th character position. Now our characters are all equally spaced in this particular example because we're putting it out to the console, right? If we had a variable spaced font, different kind of font, then you would see it wouldn't appear in the same line. Okay, so we're formatting our output. Yes?
Is this sort of like alignment?
It's like alignment. We're aligning our output and we're telling it to start counting at the first, because remember we start counting from 0 in C#. The first space is actually, the first little placeholder for text is the 0th location. And then we start counting to the right. 0, 1, 2, 3, 4. We've counted 5 spaces starting at 0.
The way we were counting was counting from 1.
But we don't count that way. The machine counts from 0. You're right. We counted from 1. The machine counts from 0. Okay, so this is some good formatting. Here's something. How about the negatives? It says 0. Here's another one I want to try here. 0, comma, and then -8. And then 1, comma, -8. And then I have Richard and Lee. Let's try this output to see what happens. So here's the example, console.writeLine, right? And I open up a string, 0, comma, -8. Close it up, right? And then next to it is, I think it's 1, comma, -8, right? 1, comma, -8. And then we have a comma as an example. If you notice, actually we have inside outside of the brackets, we have a couple more strings. But these are placeholders. So I'm going to take this string here, Richard, and replace it in here. And I'm going to take this string Lee and replace it with this one, right? 0, 1. Okay, let's do this thing. So Richard, comma, Lee, and then semicolon. Let's try it out. This line. Whoa, Richard Lee. Except it's here. Richard is here. There's a space, and then Lee. How come? What does this -8 mean anyway? The important thing to understand is that we start formatting, we say -8. It means something different than +5. When we start counting at 0, it means something different than 1. What do these two things mean? We have to figure this out, right? So here's the way we format output, right? if I go back to my formatting idea, if I go a string of characters that optionally contains fixed text, and it contains one more format items or placeholders for variable values, so I can move things around or sub in a different value, substitute a value into there. Okay. I also have the ability to concatenate two strings together by using the plus operator. Right. So if I have string number 1 and string number 2, and if you have this, you see between string number 1 and string number 2, there's a little space here. I could use this plus operator to concatenate or put these two strings together, and I'll put them together. Right. The plus operator does that. So for example, I could simply do something like this: console.writeLine, right? Richard, if we're going to do Richard Lee, space, plus Lee. And it'll be the same output as the one above it. Let's take a look.
So wait, I don't get the minus and minus 8.
I know, we're going to talk about that in a second. Okay, so Richard Lee, both lines are the same output from these two things. Right? Again, if you notice, this output and the output I gave are the same. What about this one, Marcia Parker? Is that going to be the same as Richard Lee? Let's take a look. Right? They're the same values, right? Minus 8, minus 8. Let's see what it does when we put these things together. Console.writeLine, right underneath the other one. And we'll say the same things, 0, comma, minus 8. Why the minus? And then 1, comma, minus 8. Right? And then we'll say, is it Cheryl Parker? Marcia Parker. I don't know why I thought Cheryl. Marcia Parker. Okay, there we go. Marcia Parker. Let's see what the output we get now. Marcia Parker. What's the point? Why would I bother? Marcia is 1, 2, 3, 4, 5, 6, 7, 8. Right? So what is it saying? It says, take Marcia and make sure there's 8 spaces behind her. Right? But that didn't really happen. And take Parker. If you see how Parker is aligned with Lee, that's correct. Let's take a look at that in the PowerPoint. PowerPoint's going to have some output for us, right? See how Marcia Parker, Richard Lee, and Ed Tompkins are all in the same line. It aligns all the names up. So displaying values with different numbers of digits using field sizes. And that's what this is doing. It's saying this is our field size. So
I still don't get it.
I know.
Get the minus.
I know. Don't worry, we'll get there. If you have a question as to string formats and you don't understand what this minus and thing is, where would you go to look it up if you want to do some string formatting in
W3 school?
No, W3 schools has nothing to do with C#.
Really?
Yeah. C# is a language. W3 schools is used for programming, for web.
Oh, something like that?
So if I go here to the thing and I start typing string formatting, right, C#, it'll give me all kinds of information about string formatting, right? So now this isn't what I want. String format method, that's not what I want. Custom numeric format strings, maybe that's what I want. Let's go there. So if I format string, and if I notice, here's the 0. It says format specifier 0, replaces the 0 with a corresponding digit if 1 is present. Otherwise, 0 appears in the result string. Okay. Number replaces the number symbol with a corresponding digit if 1 is present. Otherwise, no digit appears in the result. So this is a formatting methodology here. Right? Percent multiplies a number by 100 and inserts a localized percentage symbol in the result string. String. And this is not what we're looking for, right? Because it tells us how it allocates these. It's a format string. So this is not what we're looking for at all. This is like a a custom format. We're telling the numbers to replace somehow, right? So I want to format how to format a string in C#. Because that's what we're really doing. And again, it gives us the same kind of values, right? We can also put in, like what I said, C# string interpolation, which is the other thing I talked about. So interpolation strings in C# like the % operator, and Stack Overflow gives us an example of this, right? It says you can also use named parameters instead of indices. So here's my string interpolation, right? And there's some examples of how we can do that. But what is that strange -8? Well, it's a field size, right? So if I say string field size in C#. So string length, maximum string size, C# limit length of a string, specify maximum length when declaring string field key, and so on. There's different ones you can look up, but you'd have to look it up. This is where you get all your information online here, right? Okay. Needless to say, this formats our output. This +5 said move our value, right, 5 characters to the right. Right? This negative basically says we need a minimum of 8 characters. That's what it means. So I need 8 characters for Richard. For Richard's only 1, 2, 3, 4, 5, 6, 7. So it inserts a space after Richard. And the same thing goes with Lee. Lee needs 8 characters. But we're going to start at the first position as opposed to, or this is the first index as opposed to the 0th index. These are not position numbers, but rather index numbers. This is the first argument that gets interpolated, and this is the second argument that gets interpolated. Right? So the first number here is the index number, and the second number is the field size. Okay, we'll do one more, and then we'll take a break. And we'll talk about, in the middle of the break, I'll do a little random poll, right? Because we're heading into like 8:30 time frame right now. Okay, so again, data types, there's different types we talked about. We talked about variables of type int and what they hold and shorter integer types. We've talked about all this stuff before. Same thing with floating points, decimals, and doubles and decimals. They hold different significant digits of accuracy. So floating point numbers, they contain decimals, and so do doubles and decimals. They're just different data types to represent how many how much precision we want, how many numbers after the period. So if I want 0 and 7 significant digits, I use a float. If I want to do 0 dot or 1 dot or a number or integer plus this fractional piece that's 15 or 16 digits, we use a double. And if I want a decimal, then I have 29 digits of precision. Now that's only really for mathematical stuff in science, for that level of precision for a decimal. Or monetary calculations for trying to figure out things like interest. We want to be very accurate, because otherwise people will get mad at us if we use something smaller. And again, significant digits, we talk about how much accuracy, how many digits are after the number. Now when we use a float, we have to put a capital F after the literal to make it a float. Okay? If we use a double, we put a capital D. And when we want to use a decimal, we want to put a capital M next to the notation. So what that means is, if I go back to here, and if this number, if I wanted to make it a decimal, so let's say I have a decimal point, I'm just going to stop debugging here for a second, and I'm going to get rid of some of this stuff that's useless for us right now. We just did it for an example of how we're going to format our string, right? and I want to kind of make another one called a decimal, right? A big one. It's a big number, decimal. I say decimal, right? And my decimal is maybe how much money I have in my bank. That's a lot of money. That would be a lot of money somehow, right? A lot of accuracy, actually, is what it is. And let's say my money was a decimal, right? And if my money, if I only had $1,000 in the bank, like an even number like this, and I press semicolon, right? It would work. It would convert this integer, this is an integer literal, it would convert it into a decimal, no problem. But if I wanted to add something like this, right, it would start complaining. Even though this is an actual decimal in math, in real life, 1000.00, it needs to be told specifically that we want to format it as a decimal, right? So we need to put an M next to it, like this, right? 1000.00M. It's the way we format to tell the computer that we're storing a true decimal with 29 decimal places afterwards of precision into my money as a variable. Again, if instead of a decimal it was a float, right, we could then change this to an F, and that would work. And instead of a float, if it was a double, then we would change this to a D, because it would error out too, or it would actually try and convert a float to a double, right? So these little notations at the end of our literal, of our number, are just ways of telling the compiler the type of decimal, the type of number we're putting into the value. And the reason why C# gets so specific is because you can convert one type of data to another type of data, one type of data type to another type, and it happens all the time. We want to make it so that it happens explicitly as opposed to implicitly. Explicitly means we tell it to happen. Implicitly means it just happens because we put a number that's not the right number into a variable that's expecting it to be bigger or smaller. So example, if we tried to put in, if I want, yeah, it's very specific. If I wanted to put in a floating point number into an integer, what would happen? The precision, the digits after the fraction would go away, because an integer can't hold fractions. It can only hold a whole number. So anything after the decimal point is gone. Like literally, any precision, any accuracy, gone, right? We can't do that here. If I just put this, so if I know it's a double and I do one of these, right? What I'm saying is take this 32-bit signed integer, right, and convert it into a double, and it's going to chop off accuracy. It'll work, but the other way around, if I do one of these, here's an int, an integer, and I put in a decimal point like this, right, that will give me an error because I'm saying you cannot implicitly convert type double to an int. An explicit conversion exists. Are you missing a cast? It's giving me a suggestion. Do you want to cast something? And if I right click, sometimes it gives me a fix. It says, hey, you want to do something here. You want to fix this problem. And sometimes it'll give you a fix right in here on how to do that, right? We'll do casting later on. But for now, let's put it back. Let's make our money float, which is kind of more accurate. Again, another type of data that we're storing 1,000, and we're going to put an F behind it to say that, yes, it's a float. It is indeed a float that we're sending into. This literal that we're assigning it is a float. So this is the different notation we use. I'm going to pause here for now, so we take a brief break, and then we'll go, I'll put up a poll, and then we'll come back to it, and I'll ask you some questions to remind you of what we're doing.